This video lesson gives an introduction to solving trigonometric equations. We're going to be using some of the problems from Worksheet 1 for Section 8.4. If you don't have a copy of this worksheet, you should see a link to it right near the link for this video lesson on the assignments page from the Whipple Hill website. The first three problems of this worksheet ask you to determine exact values of theta where theta is between 0 and 2 pi. So reading these instructions carefully means we're supposed to give our answer in radians. That's what that means. Alright, so you've seen problems like this from earlier in this chapter, even on one of the quizzes. I think the unit circle quiz asks you questions like this. So of course we're just looking for the angle that has, or I should say angles that have a cosine of -1/2. And if you want to sketch a quick little unit circle, that wouldn't be a bad idea. Just start to think about where would we have -1/2 for a cosine. If you want to pause the video right now and give that a shot, then you can check your work with what I do. So let's see, for cosine to be negative, that means we need to be in either the second or the third quadrant here. We also know that with the number 1/2, we're not looking at one of the pi/4 angles. We're looking at either one of the pi/6 or pi/3 angles. So the 1/2 is the smaller number between, I guess there's 1/2, and we also have √3/2. So between those two numbers, 1/2 is the smaller number. Therefore, it's got to be the shorter segment between the x and the y. So I'm going with, it looks to me like that would mean we're talking about this angle right up here on the unit circle, and we'd be looking at 2 pi over 3. All right. So one of our answers is going to be theta equal to 2 pi over 3. The thing is, there may be another angle, right? We know that a lot of times most of these numbers have two angles that have those values. And so if we look on into the third quadrant, we're trying to find the angle that is symmetric, that would have the same x-coordinate as 2 pi over 3. One way to figure out what this angle would be is to think about what we call the reference angle. The 2 pi over 3 up here is pi over 3 units away from pi. It's pi over 3 units up from pi. So if we want to get to the corresponding angle down here, we would need to be 2 pi over 3 units down from pi. So if we just count along, we would have, 1 pi over 3, 2 pi over 3, pi is 3 pi over 3, so we're looking at the angle of 4 pi over 3. So that is our other answer. So theta equals 2 pi over 3, or theta equals 4 pi over 3. And now I believe we have found all the values of theta between 0 and 2 pi, where the cosine of theta is -1/2. The next set of instructions that includes number 4 talks about finding all the exact values of theta where theta is in radians, but we're finding all the values, not just the values between 0 and 2 pi. And so we're going to leave our answer in this form of a plus b times k, where k is an integer. And this is a form that you should be somewhat familiar with when we were talking about coterminal angles. So let's take a look at this. Once again, I'm going to draw a little unit circle over here. And we're looking, of course, for the angle that has a sine value of -√3/2. Let's see, so since sine is the y-coordinate, then we're going to have to be looking at either quadrant 3 or quadrant 4, right, for -√3/2. All right, so let's think, so in quadrant 4, let's see, √3/2, so it's not the pi/4 angles, it must be a pi/6 or a pi/3, and √3/2 is the bigger number, so we're looking for where the y-coordinate down here in one of these quadrants is the longer or the bigger number. So I think we're kind of onto a theme here. It would be the same idea as when the cosine was 1/2. We're looking at one of the pi over 3 angles, right? So it's that angle, and it would also be this one here that would have the same y coordinates. So there's a couple ways that you can give these answers. For the one in the fourth quadrant, probably the easiest way to say that answer is to say that theta would equal negative pi over 3. Now, of course, if we were trying to give a value between 0 and 2 pi, this would not be a good answer. It wouldn't be in the correct range. But since we're giving all the exact values, then this is fine. We just need to now include all the other angles that have that position. So we're looking at coterminal angles for negative pi over 3. So we just need to add 2 pi times k, right? And that takes care of, negative pi over 3, go around. If we start at negative pi over 3, go around once, then we'd be at 5 pi over 3, go around again. We would be at, 10 pi over 3, go around again. So we can just keep going, or we can go the other direction, right? Negative pi over 3, then at negative 7 pi over 3, then negative, 13 pi over 3 every time. All right, but we still have not included these answers over here in the third quadrant. So we have to give a second piece, and we can say or theta equals, and we just need to find what that angle is, and then just add 2 pi k to that. All right, so this is actually a familiar angle. It's the same angle we were using before, so I'll just go and write it down. That would be 4 pi over 3 plus 2 pi k. Or if you had wanted to, you could have said, negative 2 pi over 3 plus 2 pi k. All right, hopefully you're getting the hang of this. Now we're going to move into the problems where it's not, we're not going to see values that we recognize, like the root 3 over 2 or the 1/2. The next 6 problems, numbers 7 through 12 on this worksheet, you can see these are values that are definitely not the ones we're familiar with on the unit circles. So we're going to have to use our calculator to get these answers. And it says, we're going to do that as well as use reference angles to determine all the solutions here for theta to the nearest tenth of a degree. So now I'm going to let you do this in degrees and not necessarily be in radians. Express your answer in the form a plus b k, where k is any integer. Now, because we're in degrees, we're going to have to change our calculators over to degree mode. So I know a lot of you like to use the scratch pad when you're working on the calculator. If you're in scratch pad on the calculator page, then you can just go to hit the document button, go down to settings and status, option 7. Within that, it's option 2, document settings, and then make sure you change the angle over to degree and hit enter. Now when you do this from Scratchpad, it'll ask you after you hit enter if you want to have this saved as the default for all future documents and so forth. And it's okay. Go ahead and say yes, hit enter, and it'll do that. If you're in a document already and you go through this process here, it won't ask you that. It'll just save it for that particular document. You will be in degree mode. Okay. Anyway, let's get to this. So if we're trying to figure out what value of theta is, I think you guys have enough experience to know that if we want to get theta, we're going to use the inverse tangent option to do this. Now technically, what you really are doing is you're taking the inverse tangent of the tangent of theta as well as the inverse tangent of the 0.2699. In other words, you're taking the inverse tangent of both sides. And of course the inverse tangent undoes the tangent and will just leave you with theta. And we're going to have the calculator do the other part. Now the way you get inverse tangent on the calculator is by hitting the Trig button, which is right next to the 7. And when you hit that, you'll find a menu and you can go enter inverse tangent. And once you've done, plugged in your 0.2699 and hit enter, what I'm getting is 15.104. We'll just, if you're in degrees, I'll let you just, if you want to round to the nearest tenth, okay, 15.1 degrees. All right. Now let's keep in mind that we need to find all the solutions. So we need to include, let's see, if I draw a little unit circle here, we need to include not just that 15-degree angle right there, but also all its coterminal angles, right? So all the angles that if you go around once, twice, three times, and so forth. So we're just going to add to our answer, right? Plus, not 2 pi k this time, but 360 degrees times k. All right? Okay, so now we need to see if there's any other angles that also have a tangent of 0.2699. This is the tricky part when you're using your calculator. It will only give you one of the places. There's almost guaranteed to be a second place for all these answers where the tangent would be equal to this number. So we've got to think, what other quadrant would give us a positive number for the tangent? Certainly the first quadrant would, because it's right, sine over cosine, both sine and cosine are positive. So let's think, would it be the second quadrant? I don't think so. Sine's positive, but cosine's negative. How about the third quadrant? That's where sine is negative, but so is cosine. So I believe we've got it here. It would be in the third quadrant. And so we really want to think, we're looking for a place where the sine and cosine are opposites of what they are over here at the 15-degree angle. And so we want the height, or the y-coordinate, to kind of be the same, just the negative, and the x-coordinate to also be the same as the negative. So if you think about it, that's going to happen way over here, directly across from that angle. In fact, think of it this way. It's going to happen where the reference angle, by reference angle, I mean this angle between the x-axis and the terminal side. That's a 15-degree angle, 15.1 degree angle. We want to have the same thing over here between the angle between the x-axis and our terminal side also needs to be 15.1 degrees. So that means we're 15.1 degrees down from 180. All right, so we're going to have an answer of 15.1 plus 360k, or theta equal to, and let's see, if we add 15.1 to 180, we're going to have 195.1, and once again, plus, this is degrees, plus 360k. All right, and that gives us all the answers that we could possibly have with a tangent of 0.2699. Now, if you're looking at this, you might already be thinking, now, isn't there maybe a cleaner way that we could give this answer? Since these two angles lie directly across from each other, then rather than giving our answer in two separate equations here, where we're adding 360k, couldn't we just say that theta equals 15.1 degrees plus, and instead of adding 360, why don't we just add 180, right? So plus 180k. And that would also, right, include all the answers, because just every time we're adding 180, it'll take us from one answer to the next. All right, so this is the nicest way to give this answer. It's not that the other way is wrong. And here's the coolest part about tangent. Tangent always works this way, that whatever answer you get off the calculator, the other answer that the calculator does not give you is always 180 degrees away. So if you just want to automatically, when you're solving a tangent, just know, okay, I just got to add 180k, then we're there. All right. Keep in mind, though, when we're in radians, that answer is going to be a certain number of radians plus, instead of 180k, it'll just be plus pi k. And we know that's going to be the case, right? Because pi is the period of a tangent graph. Perhaps you're also already thinking this would probably work for cotangent, and indeed you're right. But many times we may just when we have a cotangent, we might just turn it into a tangent anyway. We're going to see that kind of thing on the next problem we look at here. Okay, so this is the last set of instructions for numbers 13 all the way through 18. Very similar to what we've been doing, but this time we're in radians, okay? So in I'm asking us to be to the nearest hundredth of a radian. I really should put in there a thousandth. We want to try to be doing 3 decimal places to get ready for next year. And once again, we're looking for all the angles, so you're going to express your answer in this form: a plus b times k, where k is any integer. Right, this time I've given you a cosecant. We're taking a look at the cosecant of theta equals negative 1.020. Now, you might have already noticed if you hit the trig button on your calculator, it does have inverse cosecant. So if you want to use that and just go with that, it's fine. I do want to just point out though that before we had these fancy calculators, back with the early TI-84s, we didn't have an inverse cosecant option. So what we had to do back then, if we had a cosecant or a secant or even a cotangent, is we had to change it first to either sine, cosine, or tangent. So in this case, we would come over here and we'd say, okay, so if the cosecant of theta is negative 1.020, then that must mean the sine of theta is equal to its reciprocal. So we'd have 1 over negative 1.020, and we could plug that into our calculator and get a decimal, which is negative 0.980392. I'm just trying to be as accurate as I possibly can until the end of the problem here. And so once we had this, then of course we would, to get theta, we would take the inverse sine. Keep in mind you're actually taking the inverse sine of both sides of the equation, but the inverse sine of negative 0.980 ... So let's do that. So I'm going to take the inverse sine of my answer. I'm trying to keep my accuracy, so I'm using just going up and grabbing that number on the calculator. And it looks like we're getting, oh, I'm in degree mode. I just realized, because I got a number like I got negative 78.6, so that's a clear giveaway that I'm probably not in radians here. So if you're in the same boat, go back and hit your document button, and go to 7 settings, and then number 2 document settings, and change back over into radian mode. Alright, and then just hit enter, and then you're back. Alright, and so now let me go grab that computation, and I'm getting now theta equal to negative 1.372. That looks a little better. That's more like radians. Alright, and of course we're trying to get all the values, so we're going to say plus 2 pi k. Alright, you might be wondering if you can say just plus pi k. Well, we'll check that out in just a minute. Okay, so now let's see, where is that angle on our unit circle here? If I draw the unit circle in, it's negative, so it's leading me to think that we're probably either in the 4th or 3rd quadrant, and we know we're going to be in the 4th because negative pi over 2, that's about negative 1.57, right? Cut pi in half and you're at 1.57. So we're somewhere here in the 4th quadrant, maybe right about there, and that makes sense because the sign the sign of those values in the 4th quadrant are negative. So what other quadrant should we be looking in? Well, we've seen this before, right? We also have negative values for sine in the 3rd quadrant. So once again, we need our reference angle. We know that this angle right in here between the x-axis and our terminal side is negative, let's see, 1.372. All right. So over here in the 3rd quadrant, when we're looking for the corresponding angle, and my circle is just really bad here, we want to come down the same number of radians, right, from the x-axis on the other end. So that angle right there also needs to be 1.372. All right. So it looks to me like we just need to add 1.372 to pi to get that value. So we'll have that, or theta equals pi plus 1.372, and then I'll go ahead and put in plus the 2 pi k. All right, and on my calculator, let's just do that right here. I'm going to take pi plus 1.372, and I'm getting 4.514. So we have, let's see, we have our answer right here, and we're going to say or theta equals 4.514 plus 2 pi k, and I'll give that answer. You could say it's pi plus 1.372 plus 2 pi k, and that would be fine. You know, this is still okay. I just decided, since I was giving a decimal up here, I was just going to give a single decimal here. All right, and just to mention this, I did not round any of these numbers until the very end of my problem. I kept scrolling up and grabbing numbers on the calculator, so I had as much accuracy as possible till the very end. All right, so this is basically how you do these problems. I hope this helps. There are a number of other problems you're going to be doing on this worksheet, so make sure you check that assignment. Thanks for watching.